For a large part of history, the medium in which stories and information were recorded and passed on was through written text comprising of letters and symbols. Today, language has evolved such that written text carries what the writer is trying to say very efficiently and effectively. However, its conveyance of how, or the manner in which the text was intended to be said, leaves a lot to be desired. Sure, the context, punctuations, and italicization play a large role in how the text is being read, but ambiguity in written text is ever present. Think back to the last time you read something online and you couldn't quite make out the tone of the text, or the time that you were not too sure whether that think piece writer or your friend was being sarcastic or literal when you read their text online. Emojis, which saturate the online space today, address this issue of ambiguity in an emotive tone. By filling in emotional cues which would otherwise be missing from typed conversations. Although helpful in transmitting emotions, these do not represent the sender's visceral and immediate sentiments as the message or parts of the message are being composed. Considering that much of the information we consume today are written online using digitally written text, this project aims to address temporality and ambiguity of sentiment in written text. Seemingly, there is a lack of texture in written text. Our aim with this project is to change that. In our exploration, we ask ourselves, what are the key elements as well as nuances of face-to-face communication which make these transmissions so effective? Not taking into account the immediate sensorial feedbacks between speaker and listener in face-to-face conversations, which elements of oral and gestural language can be encoded and transmitted via the text itself. Computationally humanized audio-to-text, or chat for short, intends to address the seemingly impossible task of humanizing digital text by attempting to represent and map nuances of spoken textual language into written textual elements.
During the process of face-to-face communication, the physical characteristics of the speaker supplement the vocal characteristics and verbal content, whether it will be in emphasized or in showing sympathy or conveying a certain emotion. Physical characteristics can be broken down into body movement or gesture and facial expressions, both of which make up the body language of a person. There are voluntary and involuntary body language. Voluntary body movements or gestures are performed with full or partial intention. Involuntary body movements can be things like slightly leaning forward when we are focused or integrated by something, and natural changes in facial expressions. Movements and gestures alone facilitating conveying a certain word or concept even when the person forgets and cannot say it or describe it using spoken words. The observation of both the voluntary and involuntary physical elements are informed in our design research of chat. The vocal elements of face-to-face communication convey a large component of subtextual information. These characteristics can either be voluntarily encoded or involuntarily prompted by the speaker. Voluntarily, a person can alter the tone, pacing, and volume to emphasize key points in the subject that they're talking about. On the other hand, a person may be affected in a way such that changes in their vocal characteristics are involuntarily prompted. Examples of such involuntary changes are suddenly stumbling on certain words, sudden increase in pitch and volume, or increase in tempo and pacing. Pause fillers such as and are used in face-to-face communication, which are not usually present in written communication and content. In spoken discourse, these words allow speaker to have time to order their thoughts and words. In a dialogue between two people, they allow the speaker to hold the floor to let the listener know that they are not ceding control of the floor. There is an abundance of subtextual information which can describe the speaker's sentiment on a particular subject from the vocal elements. When we listen to someone speak, we are able to derive an overall tone from what we perceive, from not only the content of what was said, but how it was said. These various aspects of vocal communication combined add meaning, emotion, and sentiment.
Typography is body language. It's what makes the first impression in text communication. Every content may contain some mundane text. If used effectively, typography can make them look attractive. The correct approach may be the use of some attractive graphics. Good typography adds a tone of the voice, which subliminally reinforces what the words say to influence how those words are perceived. And yes, there is research to back this up. The weight, texture, and shape of font combine to determine how we perceive the text and played a large part in telling the story behind this message. Typography can affect everything about how the message is perceived. Here is the typography anatomy. Each word has its unique anatomy. By understanding the anatomy of the typography, we can think about how we can change the text we want to express. The width, height, and size are the easiest to change. On the right is experiment we did. We used the edge to experiment how we can change the shape of the font. We can change the thickness of the edge and so on. And we did another experiment to see how we can change the shape of the font through body movement. I used X and Y of the mouse to simulate the possibility of changing the font shape. The abscissa become wider and alternate become higher. Through this we can change the font size, kerning, and thickness to reflect important information or emotional expression in information transmission. For example, when we express our feeling in verbal communication, we may say some words loudly, or when we send a message, we may repeat some letters multiple times according to our verbal communication habits. This will make the other people feel the focus and feeling of your message. For example, look at this sentence. I'm hungry. You can see how different weights and lengths affect the look and feel of the textual elements. Which sentences need more time to read? Let's see. I'm hungry. I'm hungry. I'm hungry. Yeah, definitely last sentence. And you can feel that you should be very hungry now, right?
By observing the various aspects of face-to-face communication and through the manipulation of typography, chat will aim to represent the spoken words of the transmitter as close to the manner in which the words were said. Of course, it is difficult to translate all verbal and non-verbal elements of the spoken manner, such as emotive tone, facial expressions, and intonations. The typographical manipulation of the spoken words will depend on the amplification, physical movement during the encoding of the message, as well as tempo rate of each spoken word and between the words. Unlike text messaging, the sender will not be given the software tools to edit his words. Instead, from when the voice recording starts to when it ends, every single said word detected by the system will be documented and sent once the recording ceases. Once the recording begins, the sender who is recording will not be able to seize and delete the recording for a second attempt. Instead, whatever has been recorded since the recording began will send. This feature is more representative of how people interact face-to-face on a daily basis.
To uncover the optimum design, the chat team underwent a rigorous process of research and experimentation. Using the identified concepts of human language and typography, we ran through many iterations of different technologies and forms. From a technological standpoint, we need to create a way of transcribing and molding the natural intricacies of a person's speech, both in its verbal and non-verbal form, into a text-based form. This requires monitoring each word that is said, the alterations in the tone of voice, as well as how a person moves when they speak. To monitor the word content of the speech-to-text programming would need to be used, preferably one that does not require large amounts of processing power or a connection to the internet. This aspect, however, leads to the need of a small computer, such as a Raspberry Pi, to run this programming. For the audio input, a small USB microphone will allow for easy input of audio for the use of monitoring the loudness of the voice, perhaps the pitch, and of course the recording of the words. Monitoring the body movements of a person required identifying a way of omnidirectionally recording the location of a person's body in space. The most notable invention that does this is an instrument known as the theremin. A theremin converts changes in the electromagnetic field to the pitch and amplitude of a synthesizer by the means of amplifying and processing the electrical input from an antenna. To use this technology, we would need to build the basis of this instrument and have it convert the signal into values that the internal computer can use. The device now needs to be housed in a body that works synergistically with the technological aspect as well as the ideological concept of the chat device. Using research techniques such as body storming and role-playing, it was apparent that the device needed to be comfortable to hold, lightweight, and robust. It also needed to visually suggest all the ways it can be interacted with so that the user can focus purely on the conversation. The physical look of the device also needed to aid the user's ability to comfortably talk to this object. How could chat be designed so that the object isn't seen just as a technological device, but as a receiver of emotions, sentiment, and conversation? Chat has been given a form that encourages the user to touch it and hold it and move around it without hesitation. The robust nature of its two-part plastic shell and steel antenna allow it to withstand dropping and knocking and other forms of physical stress. This plastic shell has been shaped with a creature-like design to encourage the users to treat it and hold it the way you would a pet. This also means a moving away from the emotional sterility that many technological objects have today. The front face of chat displays the main inputs of the device. There is a camera facing you in the top, encouraging you to make eye contact and also allowing for the pairing of your face to the message you wish to send. Underneath, there is the microphone that will record your voice to create your message. It is placed in the middle bottom of this device for optimum recording and visual recognition. This microphone allows for an accurate and clear voice recording up to 5 meters so that you can multitask to your heart's desire. On the right, there is the send and receive switch. It is tactile, audible, satisfying to use, and forefront in its position that you can easily see what mode chat is in. This switch has only 2 states to minimize the need for learning the device. 1 flick of a finger to begin the recording process, and when you are done, just 1 flick to send the message and be ready to receive a response. Protruding from the top of chat is the antenna. Using technology derived from the theremin, it monitors the electromagnetic field around chat so that your body movements and proximity to the device can be represented in the text. This antenna can sense how you move your hands as you speak, how you hold chat, or how close you are. Underneath this device, behind the front legs, lies the thermal printer. This inkless printing device will print the created message, feeding it through the legs and towards the user. The long roll of paper is heated into the messages both sent and received, which can be torn off and kept as a keepsake for the conversations had through chat. The brain of the device is a small computer, the Raspberry Pi 4, which has enough power to accurately transcribe your words using large language libraries and match the words with the characteristics of your voice and body movements that makes you you. The device is also powered by a cable from the back, as its ports are exposed through a small cutout. A user of the device would simply walk over to the chat, inspect it to see if there's any new messages, flick on the switch to start recording. Once the switch is flicked, the user has 3 seconds to get ready to pose for their picture. Now the picture is taken, all you have to do is talk. Just what do you want to say, what do you want to do, what's going on, and when it's done, you flick the switch off and it will print out.